Hello aspirants, welcome to Magic World of Physics. In this video, we're going to discuss about some questions from mathematical physics which is asked in various exams like GATE, Barc, Justifer. Hope this video will be helpful for your coming Barc exam 2026. Without any further delay, let's get started. The first question is, if A of t is a vector of constant magnitude, which of the following is true? Here it is given that a of t is a constant. Then a of t into a of t, that is equal to a of t the whole square. Differentiating this with respect to t, that is dA by dt into a plus a into dA by dt is equal to 0. So 2 dA by dt into a is equal to 0. That is dA by dt into a is equal to 0. So the option C is the correct answer. Next question is, the height of a hill at the point x comma y in meters is given by h is equal to exponential of 2xy minus x square minus 2y square minus 4x plus 8y plus 1, where x and y are in kilometer with respect to a certain origin. What is the unit vector in direction of steepest ascent at the origin? So here we know that delta h gives the direction of steepest ascent. So the delta h at the point 0, 0 is equal to e raised to minus 4i cap plus 8j cap. So this is the vector that is in the direction of the steepest ascent. To find the unit vector, we need to find the value of, that is n cap is equal to delta h divided by mod of delta h. So that is equal to 1 by root over 80 into minus 4i cap plus 8j cap. So the answer is option A. The next question is, consider the set of vectors 1 by root 2, 1, 1, 0, 1 by root 2, 0, 1, 1 and 1 by root 2, 1, 0, 1. Which option is correct? So here A is equal to 1 by root 2, 1, 1, 0, B is equal to 1 by root 2, 0, 1, 1 and C is equal to 1 by root 2, 1, 0, 1. Then A dot B cross C is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3 and this is equal to 1 by root 2, 0, 1 by root 2, 1 by root 2, 1 by root 2, 0, 0, 1 by root 2, 1 by root 2 and this is equal to 1 by root 2 into 1 by root 2 minus 0 plus 0 into 1 by root 2 minus 0 plus 1 by root 2 into 1 by root 2 minus 0 and this is equal to 1 by root 2 and this is not equal to 0. So that as A dot B cross C is not equal to 0, we can say that A, B, C are linearly independent. So the answer is option B. Next question is, if A is equal to x ex cap plus y ey cap plus z ez cap, then del square A equals dash. Here A is equal to x ex cap plus y ey cap plus z ez cap, then del square A is equal to dou square by dou x square of x ex plus y ey plus z ez plus dou square by dou y square of x ex plus y ey plus z ez plus dou square by dou z square of x ex plus y ey plus z ez is equal to 0. So that the answer is option C. Next question is, given A is equal to y square ex plus 2yx ey plus xy ez minus sin x ez, calculate the value of double integral over s del cross A dot n cap ds over the part of the sphere x square plus y square plus z square is equal to 1 above the xy plane. So here we need to find the value of double integral over del cross A dot n cap ds. So this is equal to triple integral over del dot del cross A dv. This is by divergence theorem. And we know that del dot del cross A is equal to 0. So that this is equal to, the integral value is equal to 0. So the answer is option C. The next question is, if S is the closed surface enclosing a volume V and n cap is the unit normal vector to the surface and R is the position vector, then the value of the following integral, that is the double integral over R dot n cap ds is dash. By divergence theorem, we can write double integral over R dot n cap ds is equal to triple integral over del dot R into dv. Here del dot R is equal to del dot xi cap plus yj cap plus zk cap, and this is equal to 3. So the integral value is equal to 3 into triple integral over dv. That is double integral over r dot n cap ds is equal to 3v. So the answer is option D. Next question is, which of the following vectors is orthogonal to the vector ai cap plus bj cap, where a and b are the constants and I and j are the unit orthogonal vectors? For two vectors to be orthogonal, their dot product should be 0. So in the given problem, here the vector given us ai cap plus bj cap. So we should select an option in such a way that their dot product become 0. So let us select the option A, that is minus bi cap plus aj cap dot ai cap plus bj cap, that is equal to minus ba minus ab, and this is equal to 0. That means their dot product becomes 0. So the answer is option A. Next question is, the unit vector normal to the surface 3x square plus 4y is equal to z at the point 1, 1, 7. So the vector given as phi is equal to 3x square plus 4y minus z. Then del phi is equal to 6xi cap plus 4j minus k cap. Then del phi at 117 is equal to square root over 36 plus 16 plus 1, and this is equal to root 53. So the unit vector normal to the surface is del phi by mod of del phi at 117, that is equal to 6i cap plus 4j cap minus k divided by square root over 53. Next question is, a vector A is equal to 5x plus 2y I cap plus 3y minus z j cap plus 2x minus a z k cap is solenoidal if the constant A has the value. So here A is equal to 5x plus 2y I cap plus 3y minus z j cap plus 2x minus a z k cap. For a vector to be solenoidal, then the divergence will be 0, that is a dot del dot a becomes 0. Then del dot a is, here it is 5 plus 3 minus a, and this is equal to 0, that means 8 minus a is equal to 0. Then a is equal to 8. So the answer is option C. Next question is, the curl of a vector A is equal to zi cap plus xj cap plus yk cap is given by dash. This is a very simple question. It is asked to find the curl, that is ijk dou by dou x dou by dou y dou by dou z x y. That is the answer is del cross A is equal to I plus j plus k. So the answer is option A. The next question is, for the function phi is equal to x square y plus xy, the value of del phi at x is equal to y equal to 1 is dash. So here the given function is phi is equal to x square y plus xy, then del phi is equal to 2xy plus y I cap plus x square plus x j cap. Then del phi is equal to, the mod of del phi is equal to square root over 2xy plus y the whole square plus x square plus x the whole square. Then applying the value of at x is equal to y equal to 1, we can write the del phi mod value as square root over 3 square plus 2 square. So this is equal to root 30. So the answer is option D. The next question is, the average of the function f of x is equal to sin x in the interval 0 pi is dash. We know that the average value of a function can be found out by the equation. This is equal to 1 by b minus a integral over a to b f of x. Here f of x is equal to sin x in the interval 0 pi. So the average value is equal to 1 by pi integral over 0 to pi sin x. This is equal to 1 by pi into minus cos pi. The limit starts from 0 to pi, and this is equal to 1 by pi into minus of minus 1, this is equal to 2 by pi. So the answer is option B. Next question is, identify the points of unstable equilibrium for the potential shown in the figure. We know that the unstable equilibrium is a state of equilibrium in which the small disturbance will produce a large change. So in the graph given above, here the points R and U are the points of unstable equilibrium because it produces a small disturbance and that creates a larger change. So the answer is option C. The next question is, the average value of the function f of x is equal to 4x cube in the interval 1 to 3 is dash. We know the average value can be found out by the equation 1 by b minus a integral over a to b f of x. Here a to b means 1 to 3. Then the average value of f of x is equal to 1 by 3 minus 1 integral over 1 to 3 4x cube dx, and this is equal to 1 by 2 integral over 1 to 3 4x cube dx. This is equal to 1 by 2 into 4x raised to 4 by 4. The limit starts from 1 to 3, and this is equal to 1 by 2 into 3 power 4 minus 1, and this is equal to 40. So the answer is option C. The next question is the unit normal to the curve x cube y square plus xy is equal to 17 at the point 2, 0 is dash. We know phi is equal to x cube y cube plus xy minus 17 at the point 2, 0 is n is equal to del phi divided by the mod del phi at 2, 0, and this is equal to 3x square y into I cap plus 2x cube y plus x j cap divided by mod of del phi at 2, 0, and this is equal to, by applying the value of 2, 0, we can write this is equal to 2 j cap by 2, and this is equal to j cap. So the answer is option D. The next question is, if a vector field f is equal to x I cap plus 2y j cap plus 3z k cap, then del cross f is dash. Here f is equal to x I cap plus 2y j cap plus 3z k cap. Then del cross f is equal to I j k dou by dou x dou by dou y dou by dou z x 2y 3z, and this is equal to I into 0 minus j into 0 plus k into 0, and this is equal to 0. That means del cross f is equal to 0. Then del cross f is equal to 0. So the answer is option A. Next question is a linear transformation T defined as T is equal to x1 plus x2, x2 minus x3. Transform a vector x for a 3-dimensional real space to a 2-dimensional real space, then the transformation matrix T is dash. So here we need to find which option gives the value in such a way that if it is multiplied with x1, x2, x3, it gives x1 plus x2 and x2 minus x3. So let us take the option 1, that is 1, 1, 0, 0, 1, minus 1 into x1, x2, x3 is equal to, we get the answer x1 plus x2 and x2 minus x3. So we get the matrix that is mentioned in the question. So the answer is option A. The next question is the value of r dot ds divided by r cube, where r is the position vector and s is a closed surface enclosing the origin is dash. By divergence theorem, the surface integral over r dot ds divided by r cube is equal to volume integral over del dot r divided by r cube into dv. Then here the closed surface enclosed the origin, that is r is equal to 0, that is del dot r by r cube is equal to 4 pi del cube of r. We know that integral over del cube of r is equal to 1, that is integral over v del dot r by r cube dv is equal to 4 pi integral over v into del cube of r into dv, and this is equal to 4 pi. So the answer is option C. The next question is, consider the set of vectors in the 3-dimensional real vector space R cube. Then S is equal to 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Which one of the following statement is true? So here we take A as 1, 1, 1, B as 1 minus 1, 1, C as 1, 1 minus 1. Then we check A dot B cross C. So here if we take the value of A dot to B cross C, then the value becomes 0. That means if the value becomes 0, this gives that A, B, C are not linearly independent. That means here S is not a linearly independent set. That means the answer is option A. Next question is, let R be the position vector of a point on a closed contour C. What is the value of the line integral over R dot dr? So here R is a position vector of a point, so that it is a constant value. So if we take the del cross of that R, we get the answer as 0. So by Stokes theorem we can write the integral over r dot dr is equal to double integral over del cross r dot ds. As del cross r is equal to 0, the integral value is equal to 0. So the answer is option A. The next question is, if A dot to B cross C is equal to 0 in 3 dimension, then dash. So here it is given that A dot to B cross C is equal to 0. That means the box value of A comma B comma C is equal to 0. That means A, B, C is coplanar. So the answer is option A. The next question is, the Dirac delta function delta of x can be represented by dash. We know that Dirac delta function has the property that integral over minus infinity to infinity delta of x dx is equal to 1. If we take the option B and we use this property, then we can write 1 by pi limit of e tends to 0 integral over minus infinity to infinity e by x square plus e square dx, and this is equal to 1 by pi into limit e tends to 0 tan inverse of x by e, where the limit starts from minus infinity to infinity, and this is equal to 1 by pi into pi by 2 minus pi by 2, and this is equal to 1. So this satisfies the Dirac delta function. So the answer is option B. The next question is, the length element ds of an arc is given by ds square is equal to 2 dx1 the whole square plus dx2 the whole square plus square root over 3 dx1 dx2. The metric tensor Gij is equal to dash. Here it is given that ds square is equal to 2 dx1 the whole square plus dx2 the whole square plus root 3 dx1 dx2. The general form of a metric tensor is, in 2D is, we can write it as ds square is equal to g11 dx1 the whole square plus g22 dx2 the whole square plus 2g12 dx1 dx2. Here g12 is equal to g21. So the metrics, comparing these two equations, we can write the metric tensor Gij as 2 root 3 by 2 root 3 by 2 1. So the answer is option B. The next question is, the scale factors corresponding to the covariant metric tensor Gij in the spherical polar coordinates are dash. In the spherical polar coordinates, the elementary length is written as dl is equal to dr r cap plus r d theta theta cap plus r sin theta d phi phi cap. So here the coefficient of dr, d theta and d phi are 1 r sin theta. So the answer is 1 r sin theta, that is option D. The next question is, in the most general case, which one of the following quantities is not a second order tensor? Here, stress is equal to force by area. For a stress, there are two directions. One is associated with the area and one is associated with the force. So there are two directions here. So it is a second order tensor. Then for a strain is equal to change in length by original length. There is also two directions here, that is one along with the length changing and other with the original length. So there is also two directions for strain. Then the next is the moment of inertia. Moment of inertia means the angular momentum by angular velocity. Here also two directions is involved, that is one with the one for angular momentum and another for angular velocity. Then the next term is pressure. Pressure is equal to force by area. Here also there are two terms, force and area, and force and area has the direction, but they both have the same direction. So here it is the first order tensor. So the answer is option D, because it is a first order tensor. Here it is asking about the quantities that is not a second order tensor. So the answer is pressure. The next question is, the number of independent components of the symmetric tensor Aij with indices ij is equal to 1, 2, 3 is dash. So here for a symmetric tensor Aij is equal to Aj. So if 3 off-diagonal elements are not, then we can find the other 3 off-diagonal elements, as it is a symmetric tensor. So here the number of independent components is 3 diagonal elements plus 3 off-diagonal elements. So this is 6. So the answer is option C. Next question is, the Fourier transform of a Gaussian function is of the form dash. Gaussian function is a function that can be written in the form of psi of p is equal to a e raised to minus p x square. So if we take the Fourier transform of the Gaussian function, we get a Gaussian function. So that the answer is option C. Next question is Sij and Aij represent the symmetric and anti-symmetric real value tensor respectively in 3 dimension. Then the number of the independent components of Sij and Aij are dash. For a symmetric tensor, the number of independent components can be found out by the equation 1 by 2 into n plus 1. Here n means the dimension. So here it is the 3 dimension, that is 1 by 2 into 3 plus 1, that is equal to 6. Then for an anti-symmetric tensor of rank 2 in 3 dimension, the number of independent components can be written in the form of 1 by 2 n into n minus 1. Here n means the dimension. Here n is equal to 3. That is 1 by 2 into 3 minus 1. This is equal to 3. That means for a symmetric tensor, the number of components is 6, and for an anti-symmetric, it is 3. So the answer is option B. The next question is, if two ideal dice are rolled once, what is the probability of getting at least 1 6? So here the total number of outcomes is equal to 36. Then the event of getting at least 1 6 is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. So the number of event is 11. So the probability is 11 by 36. So the answer is option A. The next question is, 5 boys and 3 girls are to stand in a straight line such that no 2 girls are adjacent. The number of ways in which this can be done is dash. So 5 boys and 3 girls is to be arranged in such a way that 2 girls are not adjacent. So it can be arranged like this: a blank, then a boy, then a blank, a boy, a blank boy, a blank boy, a blank boy, then a blank, and then a boy. So the in such a way, here we can arrange 5 boys. So here we have 6 blanks. In any of this blank we can fill 3 girls. So the arrangement is 5 boys can arranged in 5 ways, that is 5p5 into the 3 girls can be arranged in 6 blanks, that is into 6p3. So this is equal to 14400, and this is equal to 5 factorial into 5 factorial. So the answer is 5 factorial into 5 factorial. The next question is, a coin is loaded such that the head occurs with twice the frequency at tails when it is tossed. A second coin is a ideal coin. What is the probability that when both the coins are tossed simultaneously, 2 tails would occur? So let P of H1 and P of T1 be the probability for the first coin, that means the loaded coin. So here it is given that the probability of getting head, that is P of H1 is equal to 2 into the probability of getting tail, that is this is equal to 2 into P of T1. We know P of H1 plus P of T1 is equal to 1. Substituting these values in this equation, we can write 2P of T1 plus P of T1 is equal to 1. That is 3P of T1 is equal to 1. That is P of T1 is equal to 1 by 3 and P of H1 is equal to 2 by 3. And the second coin is the ideal coin. So the probability of getting tail is 1 by 2 and probability of getting head is 1 by 2. So here it is asked about the probability of getting 2 tails, that is the P of 2 tail is equal to P of T1 into P of T2, and this is equal to 1 by 3 into 1 by 2, and this is equal to 1 by 6. So this is approximately equal to 0.167. Next question is, a deck of 5 cards each carrying a distinct number from 1 to 5 is shuffled thoroughly. 2 cards are then removed one at a time from the deck. What is the probability that the 2 cards are selected with the number on the first card being 1 higher than the number on the second card? So here the total outcome is 1 2, 1 3, 1 4, 1 5, 2 1 2 3 2 4 2 5 3 1 3 2 3 4 3 5 4 1 4 2 4 3 4 5 5 1 5 2 5 3 5 4. So the total number of outcome is equal to 20. Here it is asking about the probability of a number on the first card being one higher than the number on the second card. So here the possibilities are 2, 1, 3, 2, 4, 3 and 5, 4. So the answer is this is equal to 4 by 20. Next question is, if a coin is tossed 4 times, what is the probability that 2 heads and 2 tails will result? So here the probability is Pn of m is equal to n factorial divided by m factorial into n minus m the whole factorial into p power m into q raised to n minus m. Here n is equal to 4 and m is equal to 2. Therefore, Pn of m is equal to 4 factorial divided by 2 factorial into 4 minus 2 the whole factorial into 1 by 2 the whole square into 1 by 2 the whole square. That is Pn of m is equal to 24 by 4 into 1 by 4 into 1 by 4 and this is equal to 3 by 8. So the answer is option A. The next question is the probability that the two friends having the same birth month is dash. So here let the two friends be P and Q. So here P can born in any of the month. So there is 12 possibilities in the 12 months. But if P born in January, Q should born in January. So the possibility for Q is only 1. So the probability of Q is 1 by 12 and the probability of P is P 12 by 12. So the answer is 12 by 12 into 1 by 12. So this is equal to 1 by 12. Next question is, a card is drawn from a pack of 12 cards. The probability that one of the card drawn is a 10 or a jack or a queen is dash. We know that there is 52 cards. So among the 52 cards, there are 4 10 cards, 4 queen cards and 4 jack cards. So the total number is 12. That is, the probability is 12 by 52 and this is equal to 3 by 13. So the answer is option D. Next question is, two unbiased dice are thrown. The probability that both dice show the same number is dash. So we know that the total number of outcome is equal to 36. So here it is asking about the probability of getting the same number. That means the favorable outcomes are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That is the total number of favorable outcome is 6. That is the probability is 6 by 36. That is equal to 1 by 6. So the answer is option C. Next question is, the probability of density for a random variable is a e raised to minus x for x greater than or equal to 0. Then we know that the probability for a function can be written as integral over 0 to infinity f of x dx is equal to 1. Here the function is a e raised to minus x. That is integral over 0 to infinity a e raised to minus x dx is equal to 1. And this is a e raised to minus x divided by minus 1. The limit starts from 0 to infinity and this is equal to 1. Solving this, we get a is equal to 1. That is option A is the correct answer. A square matrix is unitary if dash. For a unitary matrix, A dagger A is equal to I, and for a square matrix, A inverse A is equal to I. So here it is given that the square matrix is unitary. That means A dagger is equal to A inverse. So the answer is option B. The next question is, the eigenvalues of the matrix M is equal to 1, 1, 1, 1 R dash. So here we need to find the value of eigenvalues, that is m minus lambda I, that is equal to 1 minus lambda 1 1 1 minus lambda and this is equal to 0, that is 1 minus lambda the whole square minus 1 is equal to 0, that is 1 minus lambda square minus 2 lambda minus 1 is equal to 0, that is lambda into lambda minus 2 is equal to 0, that is lambda is equal to 0 and lambda is equal to 2. So the answer is option D. The next question is, if two matrices A and B can be diagonalized simultaneously, which of the following is true? So here we need to check which property is correct. So we know that the commutator of a comma b comma the commutator of b comma a is equal to commutator of a comma b into commutator of b comma a minus commutator of b comma a into commutator of a comma b. And we know that commutator of b comma a is equal to minus commutator of a comma b. So this can be written as this is equal to commutator of a comma b into commutator of b comma a minus commutator of a comma b into commutator of b comma a, and this is equal to 0. That means we can write the two matrices has the commutator property, that is AB is equal to BA. So the answer is option C. The next question is, which of the following is true for the matrix 4 minus 1 minus 4, 3 0 minus 4, 3 minus 1 minus 3? A matrix is said to be idempotent only if a matrix is multiplied by itself gives the same matrix. That means if we have given a matrix M and it is multiplied with itself, that means M square gives the same matrix. That means if M square is equal to M, then the matrix is an idempotent matrix. And a matrix is said to be nilpotent matrix if the matrix is multiplied with itself gives a null matrix. And a matrix is said to be involuntary matrix if it is multiplied with itself gives a identity matrix. So here the matrix given is a involuntary matrix because if it is multiplied with itself, we get a identity matrix. So the answer is option C. The next question is, the trace of the matrix of a 2 into 2 order matrix is 1 and the determinant is 1. Which of the following has to be true? So here the trace and determinant should be 1. Then the one of the eigenvalue should be 1. So the answer is option B. Next question is, the product Mn of two Hermitian matrices M and N is anti-Hermitian. It follows that here M and N are Hermitian matrices. That is, M dagger is equal to M and N dagger is equal to N. Then it is given that the product Mn of two Hermitian matrices is anti-Hermitian. That is, M and whole dagger is equal to minus Mn. And it is given that M dagger is equal to M and N dagger is equal to N. So that Nm plus Mn is equal to 0. That is the anti-commutator of M comma N is equal to 0. So the answer is option A. The next question is, a 3 into 3 matrix has the eigenvalue 0, 2 plus I and 2 minus I. Which one of the following statement is correct? So here the eigenvalues are 0, 2 plus I and 2 minus I. If we take the product, we get the determinant. That the determinant value is 0. So the answer is option D. Next question is, a real traceless 4 into 4 unitary matrix has two eigenvalues minus 1 and plus 1. The other eigenvalues are dash. Here it is given that it is the traceless matrix. Traceless matrix means the trace is 0. So that we know that the trace is the sum of the diagonal elements. So here the sum of the diagonal elements is 0. That means the sum of the eigenvalues must be 0. So if we look the options, the eigenvalues should match in such a way that the sum should be 0. So the only value that matches is minus 1 and plus 1. If we take the sum, we get the answer as 0. So the answer is option D. Next question is, the eigenvalues of the matrix I minus 1, 1, I are dash. So here the eigenvalue can be calculated by the equation A minus lambda I is equal to 0. That is, I minus lambda minus 1, 1, I minus lambda equal to 0. Then I minus lambda the whole square plus 1 is equal to 0. That is, minus 1 plus lambda square minus 2 lambda I is equal to minus 1. That is, lambda equal to 0 and 2i. So the answer is option A. The next question is, the determinant of a 3 into 3 real symmetric matrix is 36. If two of its eigenvalues are 2 and 3, then the third eigenvalue is dash. So here it is given that the determinant is 36 and there are 3 eigenvalues. So we know that the product of the eigenvalue is 36. That is, here the 2 eigenvalues is also given, that is 2 and 3. So we know that the eigenvalues are lambda 1, lambda 2 and lambda 3, and the product lambda 1 into lambda 2 into lambda 3 is equal to 36, and it is given that lambda 1 is equal to 2 and lambda 2 is equal to 3. Then we understood that the lambda 3 is equal to 6. So the answer is option B. Next question is the eigenvalues of the matrix 0 1 0 0 1 0 0 0 0 0 0 0 0 2y minus 2y 0 are dash. We know the sum of the eigenvalues is equal to the trace of the matrix. Here the trace of matrix is equal to 0. So we should select an option that satisfies the trace as 0. So the answer is option A. The next question is the trace of a 3 cross 3 matrix is 2. Two of its eigenvalues are 1 and 2. The third eigenvalue is dash. We know trace is equal to the sum of the eigenvalues, and here the trace is equal to 2, that is lambda 1 plus lambda 2 plus lambda 3 is equal to 2, and here also 2 eigenvalues are given, that is 1 and 2, that is 1 plus 2 plus lambda 3 is equal to 2. Therefore lambda 3 is equal to minus 1. So the answer is option A. Next question is one of the eigenvalues of the matrix 2 3 0 3 2 0 0 0 1 is dash. So here A is equal to 2 3 0 3 2 0 0 0 1. Then A minus lambda I is equal to 2 3 0 3 2 0 0 0 1 minus lambda into 1 0 0 0 1 0 0 0 1, and this is equal to 2 minus lambda 3 0 3 2 minus lambda 0 0 0 1 minus lambda, this is equal to 0. That is 1 minus lambda into 2 minus lambda into 2 minus lambda minus 3 into 3, this is equal to 0. That is 1 minus lambda into 4 minus 4 lambda plus lambda square minus 9 is equal to 0. Then 1 minus lambda into lambda square minus 4 lambda minus 5 is equal to 0. That is 1 minus lambda into lambda minus 5 into lambda plus 1 is equal to 0. That is lambda equal to 5, 1 and minus 1. So the answer is option D. The next question is the eigenvalues and the eigenvectors of the matrix 5 4 1 2 are dash. Here the matrix is 5 4 1 2. The characteristic equation is A minus lambda I is equal to 0. That is 5 minus lambda 4 1 2 minus lambda equal to 0. That is 5 minus lambda into 2 minus lambda minus 4 into 1 is equal to 0. That is 10 minus 7 lambda plus lambda square minus 4 equal to 0. That is lambda square minus 7 lambda plus 6 is equal to 0. So here lambda minus 6 into lambda minus 1 is equal to 0. That is lambda 1 equal to 6 and lambda 2 is equal to 1. Here we get the eigenvalues. Now we need to find the eigenvectors corresponding to 6 and 1. So for lambda equal to 6, the eigenvectors is A minus 6i into x is equal to 0. That is 5 minus 6 4 1 2 minus 6 into x1 x2 is equal to 0 0. That is minus 1 4 1 minus 4 x1 x2 is equal to 0 0. This gives the equation x1 minus 4 x2 is equal to 0. That is x1 equal to 4x2. So here the possible eigenvector is v1 is equal to 4 1. And for lambda equal to 1, we can write the eigenvector as A minus 1 I into x is equal to 0. That is 5 minus 1 4 1 2 minus 1 into x1 x2 is equal to 0 0. That is 4 4 1 1 into x1 x2 is equal to 0 0. That will give the equation x1 plus x2 is equal to 0. That is x1 is equal to minus x2. So the eigenvector is v2 is equal to 1 minus 1. So the eigenvalue is 6 and 1 and the eigenvector is 4 1 and 1 minus 1. The next question is the eigenvalues of a matrix are I minus 2i and 3i. The matrix is dash. Here the eigenvalue given is I minus 2i and 3i. We know that for a unitary matrix and an anti-unitary matrix, the eigenvalues is complex number and having a magnitude 1. But here for minus 2i and 3i, the eigenvalue magnitude is not 1. So it is not a unitary matrix and an anti-unitary matrix. Then for an Hermitian matrix, the eigenvalue should be real. Here it is not real, so it is not a Hermitian matrix. Then for an anti-Hermitian matrix, the eigenvalue is imaginary. So the answer here is anti-Hermitian. The next question is for arbitrary matrices E, F, G and H. If EF minus FE is equal to 0, then trace of EFGH is equal to dash. So this is a question that asking about the properties of the matrix. We know that for a arbitrary matrix E, F, G and H, if EF minus FE is equal to 0, then the trace of EFGH is equal to the trace of HGFE. So the answer is option A. The next question is the eigenvalues of the matrix cos theta minus sin theta cos theta are dash. Here A is equal to cos theta minus sin theta cos theta. A minus lambda I is equal to 0, that is cos theta minus lambda minus sin theta cos theta minus lambda equal to 0. That is cos theta minus lambda the whole square plus sin square theta is equal to 0. That is lambda square minus 2 lambda cos theta plus 1 is equal to 0. That is lambda equal to 2 cos theta plus or minus square root over 2 cos theta the whole square minus 4 into 1 into 1 by 2. That is equal to 2 cos theta plus or minus square root over 4 cos square theta minus 4 by 2, and this is equal to 2 cos theta plus or minus square root over minus 4 into 1 minus cos square theta by 2, and this is equal to 2 cos theta plus or minus square root over minus 4 sin square theta, and this is equal to 2 cos theta plus or minus 2i sin theta by 2, and this is equal to cos theta plus or minus I sin theta. When theta is equal to 45, lambda is equal to cos 45 plus or minus I sin 45, and this is equal to 1 by root 2 plus or minus I into 1 by root 2, and this is equal to 1 by root 2 into 1 plus or minus I. So here we understood that in option A it is given that when theta is equal to 45, the answer is 1 by 2 into root 3 plus or minus I. But here we get that the answer is 1 by root 2 into 1 plus or minus I. So option A is wrong. So if we substitute theta is equal to 30 degree, then lambda is equal to cos 30 plus or minus I sin 30, that is equal to root 3 by 2 plus or minus I into 1 by 2, and this is equal to 1 by 2 into root 3 plus or minus I. So the answer is option D. The next question is the eigenvalue of a matrix A is equal to 0 I 0 R dash. Here matrix A is equal to 0 I 0. The characteristic equation is 0 minus lambda I 0 minus lambda equal to 0. That is minus lambda minus I into I is equal to 0. That is lambda square minus I square is equal to 0. We know I square is equal to minus 1. That is lambda square minus 1 is equal to 0. That is lambda square plus 1 is equal to 0. That is lambda square is equal to minus 1. That is lambda equal to plus or minus square root over minus 1. That is lambda is equal to plus or minus I. So here we get the eigenvalue as plus or minus I. That is the eigenvalue is imaginary. That is the eigenvalue is complex and distinct. So the answer is option B. The next question is if Z is a complex number such that Z is equal to x plus iy, then Z will be either purely real or purely imaginary if and only if Z square is equal to dash. If Z square is equal to Z bar square, that means Z bar is the complex conjugate. That is x plus iy the whole square is equal to x minus iy the whole square. That is x plus iy the whole square minus x minus iy the whole square is equal to 0. That is x plus iy plus x minus iy into x plus iy minus x plus iy is equal to 0. That is 2x into 2iy is equal to 0. So the answer will be x is equal to 0 or y equal to 0. That is Z is purely imaginary or purely real. So the answer is option A. The next question is consider an anti-symmetric tensor PV with the indices I and j running from 1 to 5. The number of independent components of the tensor is dash. For an anti-symmetric tensor of rank 2, the number of independent components is given by the equation 1 by 2 into n square minus n. So here I and j is running from 1 to 5. So n is equal to 5. So the number of independent components is 1 by 2 into n square minus n, that is equal to 1 by 2 into 25 minus 5. This is equal to 10. So the answer is option B. The next question is the eigenvalues of the matrix 2 3 0 3 2 0 0 0 1 are dash. We know that the sum of the eigenvalue is equal to the trace of the matrix, that is lambda 1 plus lambda 2 plus lambda 3 is equal to 5. Then the product of the eigenvalue is equal to the determinant of the matrix, that is lambda 1 into lambda 2 into lambda 3 is equal to minus 5. So the only option that matches these two conditions is option C. So option C is the correct answer. The next question is, a 3 into 3 matrix has elements such that its trace is 11 and its determinant is 36. Then the eigenvalue of the matrix is dash. We know trace is equal to lambda 1 plus lambda 2 plus lambda 3 and this is equal to 11, and determinant is lambda 1 into lambda 2 into lambda 3 and this is equal to 36. So we should select an option that should satisfy these two conditions. So the answer is option D. The next question is, the eigenvalue of the matrices 0, 1, 0, 1, 0, 1, 0, 1, 0 are dash. We know that the trace is equal to lambda 1 plus lambda 2 plus lambda 3. This is equal to 0. So the only option that satisfies this is option B. So option B is the answer. The next question is, the matrix A is equal to 1 by root 3, 1, 1 plus I, 1 minus I, minus 1 is dash. Here A into A dagger is equal to 1 by root 3 into 1, 1 plus I, 1 minus I, minus 1 into 1 by root 3 into 1, 1 plus I, 1 minus I, minus 1, and this is equal to 1 by 3 into 3, 0, 0, 3, and this is equal to 1, 0, 0, 1, and this is equal to I. That is A into A dagger is equal to I. That is A is a unitary matrix. So the answer is option D. Next question is, two matrices A and B are said to be similar if B is equal to P inverse AP for some invertible matrix P. Which of the following is not true? Two similar matrices A and B have the same eigenvalue, same determinant and the same trace. So the answer is option C. Next question is, if minus 4.5 if minus 4 1 is an eigenvector of 8 minus 4 2 4 0 2 0 minus 2 minus 4, the eigenvalue corresponding to the eigenvector is dash. If lambda is an eigenvalue, we can write Ax is equal to lambda x, that is 8 minus 4 2 4 0 2 0 minus 2 minus 4 into minus 4.5 minus 4 1 is equal to lambda into minus 4.5 minus 4 1, and that is minus 18 minus 16 4 is equal to lambda into minus 4.5 minus 4 1. This gives lambda is equal to 4. So the answer is option B. Next question is, let X be an column vector of dimension n greater than 1 with at least one non-zero entry. The number of non-zero eigenvalues of the matrix M is equal to X transpose is dash. So this is a theoretical question. If X be a column vector of dimension n which is greater than 1 with at least one non-zero entry, then the number of non-zero eigenvalues of the matrix X transpose will be 1 always. So the answer is option C. The next question is, the eigenvalue of an Hermitian matrix are R dash. We know that the eigenvalue of Hermitian matrix is always real. So the answer is option A. Next question is, which of the following statement is true? So here, by using the properties of trace, we can write trace of AB is equal to trace of BA. So the answer is option A. The next question is, given the four vectors u1 is equal to 1 2 1, u2 is equal to 3 minus 5 1, u3 is equal to 2 4 minus 8, u4 is equal to 3 6 minus 12. The linearly dependent pair is dash. So here u4 is equal to 3 by 2 u3. That means u3 and u4 are linearly dependent. So the answer is option D. The next question is, in order to obtain a solution of the differential equation d square v by dt square minus 2 dv by dt plus v1 is equal to 0 involving voltage V and V1, an operational amplifier circuit would require at least dash. So here the given equation is a second order differential equation. So to solve the second order differential equation, we need two integrator. Then to add this differential, we need one op-amp adder. So we need two op-amp integrators and one op-amp adder. So the answer is option A. Next question is the solution of system of differential equation dy by dx is equal to y minus z and dz by dx is equal to minus 4y plus z is given by dash. So here it is given that dy by dx is equal to y minus z. This is equation number 1, and dz by dx is equal to minus 4y plus z. This is equation number 2, and we know d is equal to d by dx. So equation 1 implies d minus 1 into y plus z is equal to 0. This is equation number 3, and equation 2 implies d minus 1 into z plus 4y is equal to 0. This is equation number 4. Multiplying 3 with d minus 1, we get d minus 1 the whole square into y plus d minus 1 into z is equal to 0. This is equation number 5, and 4 implies 4y plus d minus 1 into z is equal to 0. This is equation number 4. Subtracting these two equations, we get d minus 1 the whole square into y minus 4y is equal to 0. That is d square y minus 2 dy minus 3y is equal to 0. That is d square y by dx square minus 2 dy by dx minus 3y is equal to 0. That is lambda square y minus 2 lambda y minus 3y is equal to 0. Here b square minus 4 I say this is equal to minus 2 the whole square minus 4 into 1 into minus 3 gives 4 plus 12, that is equal to 16, which is greater than 0. So here the roots are real and distinct. That is the solution y is equal to c1 e raised to lambda 1 x plus c2 e raised to lambda 2 x. This is equation number 6. So here lambda is equal to plus 12 plus or minus root 16 by 2, that is equal to 2 plus or minus 4 by 2. This is equal to 3 and minus 1. That is 6 implies y is equal to a e raised to 3x plus b e raised to minus x. Here a and b means that is the constant. Here c1 and c2 is rewritten as a and b. So z is equal to y minus dy by dx, that is equal to a e raised to 3x plus b e raised to minus x minus 3a e raised to 3x plus b e raised to minus x, that is equal to minus 2a e raised to 3x plus 2b e raised to minus x. So the answer is option A. This is the end of this video. Thanks for watching this channel.